Good afternoon, students. This is Dr. Green. This course is Nursing Research 323 NURS 323OL. We are discussing Chapter 10. This is week 11 of the course, so the course is rapidly coming to a close. A lot of information in this chapter you may find handy when you're doing Critique 2, and you have to write some appraisal of that quantitative study. So there'll be a lot of measurement in there, and this will be good information for you. So let us begin. The learning objectives are to describe measurement, the levels of measurement, identify possible sources of measurement error in published studies, critically appraise the reliability and validity of measurement methods in published studies, critically appraise the accuracy, precision, and error of physiologic measures used in studies, critically appraise the sensitivity, specificity, and likelihood ratios of diagnostic tests. We'll go a little bit light on that one. Critically appraise the measurement approaches, critically appraise the use of existing databases in studies. I'll go a little light on that one also, and critically appraise the data collection section in published studies. So let us begin. What is measurement? You know, measurement has been around for centuries. Even the Bible talks about measurement, and measurement was in practice way before the AD. So measurement is the process of quantification, assigning numbers or values to objects, events, health status. Now, when you read a research study, such as the one for Critique 2, you will need to judge the level of measurement and the trustworthiness of the measurement methods. So use this chapter to help you do that. So there are, 5 key concepts of measurement theory: the directness of the measurement, measurement error, level of measurement, and the concepts of reliability and validity. So what is directness of measurement? Direct measures determine the measures of concrete things, whereas indirect measures try to capture elements of abstract concepts, such as pain, anxiety, depression, etc. And that's because they try to capture elements of it because we cannot directly measure anxiety, pain, coping. Okay, we can only give estimates. This is a Venn diagram of the concept of pain. So the outer black circle indicates the total concept of pain. And pain can be measured using physiologic measures, the FACES pain scale, which I'm sure you're very familiar with, and observation. What is measurement error? You know, when you try to measure something, let's say you're trying to measure for curtains, right? You measure the best that you can, and sometimes you're a little bit short, and sometimes you're a little bit long. So measurement error is the difference between the exact or true measure and what is actually measured. There's 2 types of measurement error: systematic and random. So systematic error is variation in measurement values that go in the same direction. It's using, an example would be using an uncalibrated scale to take weights, so that every time you take someone's weight, say you in a week you take 10 patients' weights, if it's uncalibrated, it could give you 1 or 2 or even 3 pounds higher than their actual weight, or 1, 2, or 3 pounds lower than their actual weight. That's systematic error. So every time you use that scale, you're going to get that variation in measurement, but it will always be in the same direction, either on the plus side or on the negative side. Random error is the difference between measured values and the true value, and it is without pattern. Random error can result from just from chance, or things that just happen, such as if you're doing a study that involves blood pressure measurement, if the people who are doing the measurements are not using the correct procedure consistently, you will get a lot of random error in blood pressure measurement. So the levels of measurement. A hierarchy of measurement was developed by Stevens in 1946, and there are 4 levels of measurement: nominal, ordinal, interval, and ratio. And we will go through each one of these. So let's just talk about the nominal scale. The nominal, that word, comes from the Latin word nomina, which means name. So with nominal scales, we are merely naming categories. For example, if you were doing a study on hypertension, it's possible that you might want to organize the study subjects into 2 categories: those who develop kidney failure and those who do not develop kidney failure. Okay, so we're just naming a category. Nominal scale is considered the lowest of the 4 levels of measurement. Categories that are not more or less but are different from one another in some way. So we're not saying that kidney failure is greater than non-kidney failure, or that not kidney failure is greater than having kidney failure. But they're just different. They're mutually exclusive and exhaustive. So you're either in one category or you're in the other. You're not in both. I hope that makes sense. What is an ordinal scale? Oh, I skipped a slide. Let me go back. An example of nominal data. Another example would be gender. So the categories would be male, a 1 equals male and a 2 equals female. What is an ordinal scale? So ordinal scales, order and ranking are imposed on categories. So an ordinal measurement sorts things in order. Okay, that's a very important point there. One category is judged to be or is ranked higher or lower, better or worse. So your textbook has a nice example of the dyspnea scale, and I'll ask you to look for that. I tried to get an image of that, but I was not able to do that. The numbers must preserve the order. So 1 is the tallest, 2 is the next tallest, 3 is the third tallest. So do you see? It sorts things in some kind of order. What is an interval scale? An interval scale uses numerical distances between intervals. And your textbook very clearly stated that the scale represents a continuum of values. There's no 0 point, but an important point is that the difference between, for example, 70 and 80 degrees on the Fahrenheit scale is 10 degrees. And that is 10 degrees is equal to the same distance between 30 and 40 degrees, or 110 and 120. Okay? An example of an interval scale is the Likert scale. So this 1, 2, 3, 4, 5 with strongly agree, disagree, neutral, agree, and strongly agree. We'll talk about that Likert scale in a little bit. What is a ratio scale? This is the highest form of measurement. It's a continuum of values. There is an absolute 0 point. And data of this kind can be analyzed with statistical techniques with greater precision and strength for the purpose of determining significant relationships and differences. What's an example of ratio, another example of ratio data? Well, you are probably familiar with test scores where there's a lowest third percentile, a middle third percentile, and a top third percentile. You're also probably familiar with infants when they come in, pediatrics. When they come in for their monthly visit, they get their height and weight, and it is plotted on a graph, and that tells the pediatrician and the mother that the child is growing appropriately, or maybe larger for their size, or even smaller for their size, right? And they would be in a certain percentile. So if they're at the 90th percentile for height, that means that 90% of the population being measured is smaller than their child. This is a little summary of the rules for level of measurement. So nominal data, exclusive categories, exhaustive categories. Ordinal data has the same two in addition to ranked categories. Interval data has these three. In addition, it has equal interval categories. And ratio data has 1, 2, 3, 4, and in addition it has an absolute 0. Okay? That's why it's considered a hierarchy. One is higher than the other. What is reference measurement? Here we're talking about norm reference testing. You may, when you were in high school, you may have taken what they call the NAEP test, N-A-E-P. National Association for Educational Progress gives tests on English, math, critical thinking. So these tests have been standardized. And the standards, the performance standards, have been carefully developed over years. They've used large, nationwide representative samples, using a standardized test with extensive reliability and validity. This probably doesn't pertain to nursing research, but you may hear the term reference measurement, and they're talking about norm reference testing. Here is a question for you. Grades on a multiple choice final exam are an example of which level of measurement? Ordinal, interval, nominal, or ratio? Well, the answer is D. Grades on a multiple choice final exam are an example of the ratio level of measurement. Let's go back. Ratio. Is there an absolute zero? Yes. Equal interval categories? Yes. Ranked categories? Yes. Exclusive categories? Yes. Exhaustive categories? Yes. Okay. Criterion reference testing is comparison of a subject score with a criterion of achievement that includes the definition of target behaviors. And when the behaviors are mastered, the subject is considered proficient. So those last two slides, reference measurement and reference of measurement, are really not critical to nursing research, but the next couple of slides are definitely. What concepts are associated with reliability testing? Reliability testing is concerned with how consistently the measurement technique measures the concept of interest. Reliability needs to have dependability, consistency, accuracy, and comparability. Reliability is often expressed as a correlation coefficient, with 1.00 saying there's perfect reliability, and 0.00 indicating there's no reliability. The lowest acceptable coefficient for a well-developed measurement tool is 0.8. That would be important for you to know. Okay. So what are the types of reliability? We'll talk about this slide and the next slide. Okay. So the types of reliability. Stability is concerned with the consistency of repeated measures or test-retest reliability. Remeasurement produces similar scores. So if we give the test repeatedly, right, it will yield similar scores. Equivalence. This focuses on comparing two versions of the same instrument. So they make an instrument, but there's slightly different items on instrument 2 than on instrument 1. So the focus is on comparing two versions of the same instrument, called alternate form reliability, or it focuses on two observers, Interrater reliability, measuring the same event. Right? Are the observations equivalent? Homogeneity. This addresses the correlation of various items within the instrument, or another way to say it is internal consistency. It's determined by split half reliability, or Cronbach's alpha coefficient. Close to 1 indicates a high degree of sameness. So let's say you have a 100-item test, right? And you take the first 50 and correlate those items with the second half of the test, items 51 through 100. So the correlation, the closer it is to 1, right, the higher the degree of sameness. Interrater reliability. This is a very important concept for you. It refers to the consistency or agreement between two persons' ratings related to the content of an observed event or qualitative data. So you will, if there is testing of an instrument in a study, if you're reading a study that is primarily about instrument development, you will find statements regarding Interrater reliability. Okay, how would you critically appraise reliability in a study? This is important. This may be helpful to you in your critical appraisal or your critique of the quantitative study, which is critique 2. So number 1, what reliability information is provided? Does the author include reports of the validity of the instrument from previous studies? Did the author perform pilot studies to examine the validity of the instrument? Did the researcher report the use of data from the present study to examine instrument validity in the discussion section of the report? Here's another question for you. Which of the following is an example of random measurement of error? Actual measures smaller than true measure, including elements of hope in a measure of self-concept. Measuring blood sugar immediately after breakfast, or D, punching the wrong key when entering data into the computer. Random error, right? Isn't it possible when you're entering data into an Excel spreadsheet that you might hit 8 when you wanted to hit 9, right? Punching the wrong key when entering data into the computer will result in random measurement error. Remember, random error is the difference between the true measure or score of a variable and the measurement or score actually obtained. What is validity? Validity is the extent to which an instrument reflects the concept being examined, right? How true to reality is it? The extent to which it includes the major elements of the construct being measured. And validity is determined or accomplished by comparing the items of an instrument with varying literature on the topic, verification by a content expert in the area, verification of the items of the instrument by a content expert in the area, or potential subjects' opinions about the instrument items. Now keep in mind, if an instrument does not have acceptable validity, it is not valid or appropriate to use it in a study. Okay, there are 5 factors associated with physiologic measures. We must have accuracy, precision, specificity, sensitivity, and a concern about sources of error. So let's talk about the first 2. Accuracy is how accurate is the measurement. That is, how far from the mean of the measurements is the actual mean. How accurate is the measurement? Precision refers to how precise is the measurement. Do repeated measurements yield the same measurement value? Specificity and sensitivity have to do with testing. So specificity refers to the ability of a test to rule out a condition if it is indeed absent. Think of the TB test, right? The number of true negatives divided by the true absence. Sensitivity refers to the ability of a test to detect a condition's presence if it is indeed present. That is, there are few false negatives with this test. It's the number of true positives divided by the true occurrence. So we're talking about physiologic measures. Now, sources of error that come up in measurement with physiologic measures The environment can introduce error. The user can introduce error. The subjects themselves can introduce error. The equipment may be faulty, and the interpretation of the findings may be faulty. Okay, back to critical appraisal. How would you critically appraise methods of measurement? So in your quantitative study that you'll be critiquing, there will be a section on the methods used to measure the variables. And you can ask and answer some of these questions. Okay? Were the measurement strategies clearly identified and described? What level of measurement was achieved by each instrument? Was the reliability of each measurement method adequate? Was the validity of each measurement method adequate? If physiologic instruments were used, were they accurate and precise? What measurement strategies are employed in nursing? Well, we use physiologic measurements, certainly. Blood pressure, pulse, temperature, core temperature, arterial blood gases, intake and output, serum levels of drugs. Those are all physiologic measurements. Observational measurements. I once participated in a study where we had to make rounds of intensive care units to see what the nurse was doing at that particular time. So those were observational measurements. And interviews, we can talk to people, right? And interview them, perhaps with a questionnaire or a survey, and that would be a way of measuring something. Examples of physiologic measures are ECG, BPO, intake and output, pulse ox, smears, cultures, sensitivities. What are observational measurements? So observational measurements in both types of research, quantitative and qualitative, should be verified by a second rater. So we're back to this concept of inter-rater reliability. And inter-rater reliability, that number should be provided in the research report. So we have unstructured observations and we have structured observations, right? So if with unstructured observations, the researcher would be observing, speaking to someone, letting that person speak back to them, right? And that's their data. But in structured observations, there's some category system in operation, there's some checklist, some rating scale. How would you critically appraise observational measurements? Is the object of observation clearly identified and defined? So, for example, the study that I told you that I participated in, where I had to go at specified time periods to the intensive care units to check off exactly what the nurse was doing at that time. So it was clear what the object of my observation and the observations of others was supposed to be. Is inter-rater reliability described? Okay. Are the techniques for recording the observations described? So reliability is concerned with all of the following, but which of the following in relation to measurement? Accuracy, consistency of measurement, homogeneity, systematic error. So reliability is not concerned with systematic error, but rather with random errors of measurement. Very interesting. So you understand what systematic error is and random error. So reliability is concerned with random errors of measurement, not systematic error. Unstructured interview questions. Here are some examples. The researcher might say, tell me about such and such. Or what has been your experience with ostomy, your own ostomy care? What was it like to hear that you have cancer? Okay, so you can see it's unstructured. The question is pretty broad and open. It's not a yes-no question, so it gives the interviewee an opportunity to tell their story. Now, in a structured interview, the researcher is concerned with describing the interview questions, or writing the interview questions, pre-testing the interview protocol, training the interviewers, preparing for an interview, the use of probing, and also concerned with recording interview data. So here we're talking about primarily qualitative research. How would you critically appraise interview methods? Do the interview questions address concerns expressed in the research problem? We spend a lot of time talking about the research problem, right? Once you get your research problem stated as a question, it directs your research design and your hypothesis, right? And your statistical analysis. Are the interview questions relevant for the research purpose and objectives, questions, or hypotheses? Does the design of the questions tend to bias subjects' responses? Does the sequence of questions tend to bias subjects' responses? So in qualitative research, you know, there are sometimes they use focus groups. So for example, a focus group on women who have breast cancer who are being followed by a case manager, right? The focus groups of a group of women who are being followed by a case manager could be used to study qualitative issues. And the purpose is to obtain the participants' perceptions of a narrow subject in a group interview session. So let's say there's a group of 8 people who are being interviewed. They are in a room together, and they hear the responses of others and can respond to those. It gives a group a feeling of safety in numbers. Nonverbal approaches are included, and the discussion helps to provide a depth of data. Considerations. You may sort participants into smaller groups with common characteristics. That's called segmentation. You need to select an effective moderator to keep the discussion on track. The setting should be relaxed and comfortable. High quality recordings should be made of audio recordings should be made of the discussions. Then those audio recordings are transcribed. How would you critically appraise the use of a focus group? What was the aim of the focus group? Was the group size appropriate for the focus group method? Was the group sufficiently homogeneous to speak candidly? Was the moderator successful in keeping the discussion focused? Also, was the aim of the focus group achieved? Did conclusions appear to be representative of the group? and were minority positions identified and explored. What measurement strategies might be employed? So there's a variety of measurement strategies. Questionnaires. A questionnaire is a self-report form to elicit subject information, and they can self-report in written, verbal, or an electronic form. Another measurement strategy would be the use of a scale. Scales are a self-report form to measure psychosocial or physiological data. The item scores are summed to obtain a single score. Rating scales, Likert scales, and visual analog scales are all examples of scale measurement. What measurement strategies might be employed? Okay, so we're continuing here. We talked about questionnaires, we talked about scales, and now the Q methodology. Another term that means the same thing is Q-sort, S-O-R-T, Q-sort methodology. And this is a systematic study of participants' viewpoints, and they rank and sort a series of statements. Diaries, where the subjects would keep a diary, for example, their experience undergoing chemotherapy. Okay, that would be an appropriate measurement strategy. And the last measurement strategy is called the Delphi technique. This is a group forecasting technique that uses estimates from experts and uses feedback and feedback summaries of these estimates to gain additional estimates until consensus is obtained. So there's several rounds of this getting feedback, and then another round of getting feedback, and then another round of getting feedback until consensus is reached on a particular topic. I know that the Delphi technique has been used when the NANDA, the North American Nursing Diagnosis Association, was beginning its work with nursing diagnoses and trying to come to consensus on what defining characteristics needed to be present for a particular nursing diagnosis to be included in the NANDA taxonomy. What are the types of scales? Well, we've talked about it a little bit before, but scales are self-report instruments. They're rating scales, they're the Likert scale, the semantic differential scale, and the visual analog scale. So with rating scales, there has to be 5 or more items, and the categories are listed in order. And then the person selects from those categories. A Likert scale is used to measure opinions or attitudes. The semantic differential scale measures the meaning of things, or the meanings of a concept. They're trying to derive the emotional meaning of a concept from the subjects, and it measures the attitude toward a topic. And last, the visual analog scale. This consists of 10-centimeter lines with right-angle stops and short phrases as anchors at both ends. And we'll give some examples of these different scales. Okay. This is a numeric rating scale on pain. So here we have 10 intervals, 2 stops at either end, and no pain is 0, moderate pain is 5, and unbearable pain is 10. Okay, and then the subject would select which number correlates with the type of pain that they're, the amount of pain that they're having. A visual analog scale, this doesn't have any numbers here, but it has two ends. No pain, pain as bad as it can possibly be. And the subject then draws a line through the brown line here, or red line, whatever that is, to indicate the pain that they are experiencing. So they're quantifying their pain by drawing a line on this horizontal line. This is an example of a Likert scale and the items. Okay, so you have across the top here, strongly disagree, disagree, uncertain, agree, and strongly agree. And on the left hand down the page, people with cancer almost die. Chemotherapy is very effective in treating cancer. We are close to finding a cure for cancer. I would work next to a person with cancer. Nurses take good care of patients with cancer. And then the subject would rate whether they strongly agree, strongly disagree, disagree, etc. This is a depression scale, and the scale contains a number of items. For example, I was bothered by things that usually don't bother me. I do not like eating. My appetite was poor, right? And they would circle 0 for rarely or none, 1 for some or little, 2 for occasionally, 3 for most of the time. And R would be no response. So this entire lecture has been focused on measurement during a study. Now we'll switch gears and we'll just talk about the data collection process. We just have a few slides on this, but when you're doing research, whether it's quantitative or qualitative, the data collection process must be consistent or the same throughout the study. So whatever data is being collected on subjects, it has to be collected on everybody. The report, the authors should report the subject recruitment strategies. They should report what controls they've used to decrease threats to internal validity. And regarding the intervention must be delivered in the same way every time throughout the study. This is a word you should know. What is serendipity? Serendipity is the accidental discovery of something useful or valuable when you're not looking for it. It can lead to new insights, new theories, and later studies. So let's go back to the beginning. Okay. In this integrity lecture, we have described measurement and levels of measurement, sources of measurement error in published studies. You have learned how to critically appraise the reliability and validity of measurement methods in published studies. Critically appraise the accuracy, precision, and error of physiologic measures used in studies. You've learned how to critically appraise sensitivity, specificity of diagnostic tests, critically appraise the measurement approaches, the use of existing databases in studies, and critically appraise the data collection section in published studies. Just one moment. I have one more comment to make. This critically appraised the use of existing databases in studies. Some researchers do not go out and collect their own data. They use information that has been collected by somebody else, and it usually contains many subjects, enormously large trove of information on variables. Usually that has something to do with the government, some regulatory body, or private entity. There are many nurses who are getting into this, people who are very interested in the statistical aspects. So studies that obtain data from existent databases should specify in the research report the reason that the existent data was preferable to newly collected data. And finally, critically appraise the data collection section in published studies. So we have covered all of the objectives. So read chapter 10 and pay attention to the slides that have to do with critical appraisal. All right, thank you very much. This is the end of the lecture.